Hi, in this video, let's talk about sine graph. So this is a pattern graph, y equal to sine x. So here I'm going to introduce you few terms that I'm going to use in this video. First, amplitude. What's amplitude? Amplitude is the distance between the maximum point and the midline of the trigonometric function. So this midline is a middle line. So in this situation, the midline is the x-axis. So the distance from the maximum to the midline or minimum to the midline. So in this situation, the amplitude will be 1. Okay? Or sometimes you hear people say that the amplitude is actually half the distance between the maximum and minimum. It's actually the same thing. Now you try to look at this. Maximum and minimum, it's 2 units, right? So half of it will equal to 1 unit. These are the few ways to determine the amplitude of a trigonometric function. Okay, second, period. What's period? So period is the angle required for the graph to complete a full cycle. Now you notice that this graph needs 360 degrees to complete a full cycle. Therefore, we say the period of this graph is 360 degrees or 2 pi radian. Okay, so in this video, we will focus on this subgraph y equal to a sine bx plus c. So I will share with you how do this a, b, c change affect the sine graph. So in the futures, you will learn about this one. This is not in SPM. When you see a graph y equal to a sine bx plus c plus d, so this type of graph will actually involve horizontal shift. Let me show you what's the horizontal shift. Now this is y equal to, let me write over here, y equal to a sine bx plus c plus d. Okay, now the a is 1 and the b is 1 as well, and the c is 0, d is 0. Okay, when I change this number, the graph will actually shift horizontally. You see? This is horizontal shift. So in SPM, we do not focus on this. We only focus on this, and this. Okay, so forget about the horizontal shift first. Now let's look at this. Focus on this number y equal to a sine bx plus c plus d. Now I'm going to show you how the a change affect the graph. So this a actually will tell us the amplitude. If you see 1, the amplitude is 1. If you see -1, the amplitude is 1 as well. Amplitude is the distance between the maximum point and the midline or minimum point at with the midline. So it will be always positive. Even though you see negative here, now let me show you here. If this is negative, the graph will actually change, become like this. Where is the amplitude? Distance between the midline and the minimum point or the midline and the maximum point. Still 1 unit, right? Okay. Now let's focus on positive number first. So this number will tell you the amplitude of the graph. If you see 0.5, it means that the amplitude is 0.5. The midline to the maximum or the midline to the minimum takes 0.5 units. So if it becomes 2, now this tells you that the amplitude of this graph is 2. For this sine graph, midline to the maximum 2 units, right? Can you see it? 2 units. Midline to the minimum 2 units as well. Okay. So at the back here, this number will cause the graph to shift vertically. Now let me change this back to 1. Change it back to 1. Okay. Now this is plus 0. So this graph is actually y equal to sine x. So now I'm going to add some number at the back here. You will notice that this graph will go up and down. 1 is go up 1 unit. Let me change it back to 0. If negative 0.5, go down 0.5 unit. If negative 1, go down go down 1 unit. Okay, you also notice that now when this is 0, the midline is over here, which is y equals 0. If this is 0.5, the midline is over here, y equals 0.5. If this is negative 1, you will notice that the midline is over here. Midline is middle line. Okay, so this means that when you look at this number at the back here, you actually know the middle line of the trigonometric function. Okay, later on I will show you how do we sketch this type of graph. Let me change it back to 0. Okay, and the last one, this number will actually affect the period of the graph. Now this is y equal to sine x graph. The period is 360 degrees. So if I change to 2, now what will happen? Okay, so what's the new period over here? Period is the angle required for the graph to complete one full cycle, right? One full cycle is over here, which take 180 degrees. So how do we get this? So the period for a sine graph is equal to 360 degrees, the period of the original graph, the period of the parent graph, divided by the number here. So this is 2 divided by 2. You will get 180 degrees. Okay? Or if the question give you asks you to sketch a graph, use the angle in radian, then it will be 2 pi divided by 2. Okay, so remember the period for y equal to sine x, the parent graph, is equal to 360 degrees or 2 pi radian. So let me show you another one. So how about if I change this to 3? Okay, so try to observe this graph. What is the period of this graph? One full cycle takes 120 degrees, right? How do we get the period? So you remember what I told you just now? To calculate the period of a sine graph, take the period of the original graph, which is 360 degrees or 2 pi radian, divided by the number here, 120 degrees. Okay, so this number will actually affect the period of the graph. Now let me show you how do we sketch this type of graph. Okay, now I have a trigonometric function over here. Y is equal to sine x plus 1. So you will notice that the graph, you have a plus 1 over here. It means that this whole graph will be shifted upward 1 unit. And you also know that the midline is actually equal to y equal to 1. And the amplitude here, you will see nothing here. It means the amplitude is equal to 1. And because we don't have any number here, so the period will remain unchanged. Okay, now let's start to sketch this graph. Okay, this is positive 1. Let me write over here. Positive 1. This is positive 1 midline, and because the amplitude is 1, so I'm going to add 1 for the maximum point, 2, and this 0 is for minimum point. The period remain unchanged. So now I have 4 interval, right? So here also the same thing, 90, 180 degree, 270, and 360. 90 degree, 180 degree, 270 degree, and 360 degree. So this is x, this is y. Okay, so we just need to plot the critical point, and then we just connect all of them together. So let me draw some dotted line first. So if you are drawing in plain paper, you need to draw some dotted line to guide you to plot the point. Here actually I have the small grid. I don't have to draw the dotted line also, no problem. Okay, now just refer to this graph and we'll be able to draw this graph easily. So first point is over here, first point over here. So we start from here, midline. The midline is over here, right? So the first point is a intersection between the midline and the y-axis. So same thing here, the midline and the y-axis over here. First point over here, and then second point maximum. Third point go back to the midline, then go down, then go back to the midline. Okay, just refer to this graph, and then we just connect all of them together. Okay, this is a way how do we sketch a sine graph. Let's say you are not sure whether the graph is correct or not. You always can use your calculator to help you to check it. Now just key in this sine x plus 1 and press calculate, press 0. You get 1, press calculate again, press 90. You get 2, press calculate, 180. You get 1, press calculate, 270. You get 0, and the last one, calculate, 360. Okay, 1. Okay, just now I forgot to give you the range. So let's say the range requested by the question is from 0 degree to 360 degree. So if the given range is in degree, so we label the axis in degree. If let's say the given range is in radian, then we will be labeling all these axes with radian. So this is pi over 2, this is pi, this is 3 over 2 pi, and this is 2 pi. Okay, depend on the question. So for this video, I think I will use degree to show you all the graph, because I think using degree easier for you to understand. Okay, now let's look at this one, y equal to 2 sine x. So you know that the amplitude will change, the amplitude will become 2, and we don't have any horizontal, we don't have any vertical shift, because at the back here is plus 0. It means that the midline still over here, y equal to 0. And the period remain unchanged because this is 1, right? 1 same as the parent graph. So the only thing changed here is the amplitude. So how do we sketch this graph? It's actually very easy. Now let me draw the axis first. So 2. So this is 1. Okay, let me write over here 2. I think I make it longer. Okay, this is 1 and this is 2. Okay, don't have to label 1, is okay. We only want to plot the important point, the critical point. So this is -1, -2 over here. Okay, this is midline. This is x, this is y. Okay, so it's actually very easy. The first, I forgot to label the x-axis. So same thing, I want you to draw the graph from 0 degree. Okay, this time let's use pi. Let's use radian. Let's say I want you to sketch a graph from 0 radian to 2 pi radian. So seeing the given range is in radian, so we'll be labeling the x-axis with radian. So this is pi over 2, and this is pi, this is 3 over 2 pi, and the last one is 2 pi. Okay, the first point is over here, so the first point is over here, and the second point is over here, maximum point. So here's doing the same thing, and then go back to the midline, go back to the midline, and then go down minimum point over here, and then go back to the midline. So what do we need to do next is just connect all the points together. Okay, so this is a graph y is equal to 2 sine x. Same thing, if you are not sure, you always can use your calculator to help you to check your answer. Okay, now let's try to sketch another graph. Y equal to negative 1 over 2 sine x. Now you have a negative over here. So we know that the amplitude is 0.5. 0.5 unit, and we don't have the period remain unchanged because this is still 1, and we don't have any vertical shift. At the back here is 0, means that the midline is still here, y equal to 0. Okay, now let me sketch a graph. This is y and this is x. 90 degree, okay. The x is from 0 degree to 90 degree. Oh, not to 90 degree, 360 degree. So this is 90, and then this is 180, 270, and the last one is 360. So this is origin. Okay, 0.5 over here, negative 0.5 over here. Okay, once we have labeling, we have labeled all the y-axis and x-axis, then we can plot this graph easily. So the first point over here, the second point maximum, second point maximum. Okay, this is not a correct answer yet. Later on, I will show you how do I change this graph to become a correct answer. Okay, third point, and so on. Okay, let me connect all this. Oh, sorry. Let me use dotted line first, because this is not the final answer yet. Okay, so what I'm drawing here is not this graph, but is equal to y equal to 1 over 2 sine x. But because of the negative over here, so the graph will go opposite way. The positive 0 remain unchanged because 0 and negative 0 is the same thing. So 0.5, it will become negative 0.5. Let me use another color. 0.5 become negative 0.5. So 0 still remain unchanged. So negative 0.5 will become positive 0.5. So this remain unchanged. So to find the graph will be like this. So this is our final answer. Y equal to negative 1 over 2 sine x. Okay. Now let's try to sketch this graph. So we have sine 2x. So the 2 here will actually change the period of the graph. So same thing, the range of x is from 0 degree to 360 degree. Amplitude still 1. Then we don't have any vertical shift. So for this one, since it changed the period, right? So the x scale will also change. So in this parent graph, the x scale is 90 degree. 90 degree. So you notice I keep on adding 90 degree, right? So this one will be a little bit different. So first, I'm going to find the period. Still remember what I told just now. For sine graph, the period is 360 degree, right? So since now this is 2x, so what I'm going to do is take 360 degree divided by this number 2, you will get 180 degree. So this is the period of this graph. It means that it will take 180 degree to complete a full cycle. And next step, I want to find the x scale. So in this situation, the x scale is 90 degree. Now this, I'm going to take this divided by 4. Why do I divide it by 4? Now this is 1, 2, 3, 4, right? Therefore, I divide it by 4. Okay, so this will be 45 degrees. So now I can start to draw the y-axis and x-axis. Okay, you will notice that I keep on adding 45 degrees, right? Because that new x scale is 45 degrees. So because of this 2, in the pattern graph, it takes 360 degrees to complete one cycle. Now, this is 2x, so in 360 degrees, there will be 2 cycles. Let's see, is that true? There are 2 cycles. So the amplitude is still 1. Still 1. Okay, now we can start to plot. First point over here. Second point on the top, maximum point. And then go back to the midline. Go down. Go back to the midline. Go up. Keep on repeating the same thing. We should be able to get 2 cycles. Now the next step, you just need to connect all these points together. Oops, it's not that smooth, the graph. Let me change a little bit here. Okay, so this is a graph. Y equal to sine 2x. Let's see. One cycle. The period is 180 degrees, and then we have another cycle. So there are 2 cycles over here. So we look at this number, we actually can know that how many cycles within 360 degrees, 2 pi radian. Okay, let's try one more. So this will be a little bit complicated. Y equal to modulus 2 sine 3 over 2x plus 1. So for this, I'm going to sketch this graph first, so to let you see clearer how the graph changes. Okay, first I'm going to sketch this graph. Y equal to 2 sine 3 over 2x first. After that, I'm going to modulus it, and then I add 1 to it. So same thing. How about this time we try using pi, using radian. So the x is from 0 radian to 2 pi radian, which means 0 degree to 360 degree. Okay, now when you look at this 2, you know that the amplitude is 2. This means that the distance between the maximum and the midline, there are 2 units. Same thing, the distance between the midline and the minimum, there are 2 units as well because of the 2 here. And we don't have any vertical shift because this plus 0, and the period will change. When you look at this number, this 3 over 2 is mean 1.5. So we know that within 360 degrees or 2 pi radian, from 0 to 2 pi radian, that should be 1.5 cycle. Okay, since the period changed, so let me find the new period first. So the period will be equal to, since the given range is in radian, so I'm going to use 2 pi divided by this number, divided by 3 over 2. So it's actually equal to 2 pi times 2 over 3. So this will give us 4 over 3, right? 4 over 3 pi radian. And now I'm going to find the x scale, the interval. So I will divide this number by 4. Why? Because as I told you just now, there are 4 intervals over here. 1, 2, 3, 4. So take 4 over 3 pi divided by 4. This is actually the same thing as 4 over 3 pi times 1 over 4, which means 1 over 3 pi. Okay, now I got the x scale, and I know there should be 1.5 cycle within this range, and the amplitude is 2. So I can start to sketch a graph now. Okay, because the x scale is 1 over 3 pi, I keep on adding 1 over 3 pi. So this is 1 over 3 pi, 2 2 over 3 pi, 3 over 3 pi, which means pi, and so on. Keep on adding 1 over 3 pi. Okay, now I can start to plot the graph, plot the critical point, the important point, and then we just connect all of them together. So the first point is over here, and second point over here, and then go back to the midline, go down, go back to the midline, go up again, go back to the midline. Okay, so let me just connect all this point together. Okay, this graph is not really smooth, but I just it should look like this. Okay, now I'm going to add a modulus to it. So when I add a modulus to it, it means that the negative part will become positive, right? So this part will go up. So -2 will become +2. Then we just connect them together. Okay, it's not that nice. Let me draw it again. Okay, so this is a graph. Y equal to modulus 2 sine 3 over 2x. Okay, the next step, I'm going to add 1, means that this graph will be shifted horizontally, shifted vertically upwards 1 unit. So what I'm going to do now is, okay, I need to extend this vertical axis. Add 1 more unit. Oh. 2 add 1 more unit become 3. Okay. And I also need 1. Now, the whole graph will be shifted upward 1 unit. So 0 will become 1. Pi over when x is equal to pi over 3 radian, this is 2, right? Go up 1 unit. And here do the same thing. Go up 1 unit. All the point go upwards 1 unit. Okay. So then we just connect all this together. Okay, this is our graph, not that smooth, but it's okay. This is what basically this is the way how you sketch a graph. How do we sketch a trigonometric function? Okay, let me write down the function. 2 sine 3 over 2x modulus 2 sine 3 over 2x plus 1. So as I told just now, let's say if you want to double confirm whether this graph is correct, you can key in your calculator. Now, modulus is over here. So 2 sine 3 over 2x. Let me. Okay, is that correct? Yes. Then add 1. Press calculate. Then set to 0 first. Oh, sorry. I think I need to press calculate. Oh, it cannot. Let me check again. Oh, sorry, just now I forgot to key in the x. Let me redo it again. 2 sine 3 over 2x. Just now I forgot to key in the x. And then add 1. Okay, now this time should be okay. Press calculate, then 0 is equal to 1. Okay, this point correct. Then press calculate again. Pi over 3 is actually 60 degrees. Press 60. Okay, 3 correct. So this is 60 degrees. So here will be let me calculate. 120. Press calculate. 120. Keep on adding 60 and then 60. 180. Okay, correct. 240. Okay, correct. 360. Oh, sorry. 240. 300. Calculate 300. Yes, correct. And the last one, 360. Okay, all correct. So these are the way how do we sketch a sine graph. That's all for this video. See you in the next video. Bye bye.